We're solving problem 22 from the 2023 F equals MAA exam. Two springs with different spring constants are connected in three ways as shown. In the second case, the springs are connected to opposite ends of a string which runs under a massless frictionless pulley. In each case, the two springs act like a single spring with an effective spring constant Ka, Kb, or Kc. Which of the following are correct? From this problem, we can derive three formulas representing the sums of our respective spring constants in all these parts. One representing the reciprocals of the sums to be our value Kc. So we already have two of the values. We just want to find K of B. So we want to now consider the second case where if you have two springs like so, and you apply a certain force to it, and it goes down and displaces by x, well, the respective spring constants of that now are going to be F1, x1, and F2, x2, respectively. So, we can now denote that K of B, the spring constant, is equal to F over x. And we have that, so we just want to start finding things that are equal to f and x so we can complicate this formula to get a more accurate approach. So we can start by saying that we know that x1 plus x2 is equal to 2x because these springs have displaced an equal amount. It might not look like that, but this figure is not drawn to scale. We also know that our force is equal to 2 times t, where t can be represented as the two spring constants, k1, x1, or k2, x2. So we have this, and we can also note that this first equation here, this can be rewritten when dividing both sides by 2. So we get x1 plus x2 divided by 2 is x. So now that we have all these formulas for variables that we know, we can plug it into this value formula of K of B. So K of B is equal to 2t over x1 plus x2 over 2, where this over 2 simply multiplies this denominator by 2, which is 4. And after plugging in all these values, we can simplify this down. K of B is equal to 4 times K1, K2 over K1 plus K2. Therefore, we can make a direct comparison to KB and KA, or C. So now that we have this, we know that K of A is greater than KB. So by various, we can denote this and prove this by various ways. And we also know that K of B is greater than K of C. So we have this as our total sorting of the spring constants, which is our answer.